We're going to talk about polyprotic acids today. So many acids are monoprotic. They have one removable proton. And so for example, hydrochloric acid or nitrous acid, they both have one acidic proton. Polyprotic acids have more than one removable proton, usually two or three. So in this example we have phosphoric acid, and the first equation at the top is the removal of the first proton, which leaves H2PO4-, which is dihydrogen phosphate. And then that dihydrogen phosphate can lose a second hydrogen ion to form hydrogen phosphate. And then that hydrogen phosphate can lose its last proton to form phosphate ion. Another example is sulfuric acid. Sulfuric acid is a diprotic acid where the first proton is essentially 100% ionized. It's a strong acid for the first proton only, so you see a single arrow to the right. Then hydrogen sulfate or bisulfate ion will lose its second proton to form sulfate ion. Phosphoric acid is not only called a polyprotic acid, but to be very specific you would call it a triprotic acid because it has three removable protons. Sulfuric acid is considered a diprotic acid because it has two removable protons. These are several examples of polyprotic acids. So you can see carbonic acid, which is H2CO3, sulfuric acid is H2SO4, and boric acid is H3BO3. So in each case you see that the hydrogen ions are connected to the oxygens which surround the central atom. In the case of carbonic acid, the central atom is carbon, sulfuric acid it's a sulfur, and boric acid, of course, it is boron. Here you see the different Ka values for different polyprotic acids. So Ka1 and Ka2 for carbonic acid, and then if you look at phosphoric acid, there are three Ka values given. If you'll notice, for each of these, Ka1 is always much larger than Ka2, at least 3 orders of magnitude larger. And then Ka2 is always larger than Ka3 for a given acid, right? So what that means in practical words is that the first proton is easier to remove. That reaction lies further to the right. It gets successively more and more difficult to remove the proton each time. So H3PO4 is a stronger acid than H2PO4-, which is a stronger acid than HPO4-2. These are what the Ka values will look like on your table. You can see there's actually three different columns, Ka1, Ka2, and Ka3. There will only be a Ka2 and Ka3 field populated if it is a polyprotic acid. The monoprotic acids, it's just there's nothing listed there. And this is just the second half of the table.